Hello and welcome to Education at SSPJ online video tutorial. In this video tutorial, we will take up chapter Force and Pressure and discuss the NCERT textbook questions. Here we go. Discussion on textbook questions, force and pressure, right? The first question is, give two examples each of situations in which you push or pull to change the state of motion of object. Right? Change the state of motion of object means you are either changing the speed or making the object to move with a less speed or more speed or position. All that you are changing. And how many examples you can see in a day-to-day life? You are sometimes pulling the drawer and pulling it so fast sometimes and pressing it so hard, the toothpaste, and sometimes, when you play football, you're kicking moving ball. So many examples are there. So I am not giving any specific examples here. You have to write your own examples, right? And write your own examples, not by just picking up from the Google search or any material. So anything which is related to your day-to-day life situation, you pick up and write. That is what is required. Next question. Give two examples of situations in which applied force causes a change in the shape of an object. Right? Change in the shape. Remember, force causing change in the shape. Right? And many occasions we see throughout. Right? I want you to write your own examples, not the examples which I am telling here. So here I am simply taking one examples where generally when we hammer, what happens, we miss the target and then the nail gets bent. That's one example of change in shape. And the best example, every one of us, okay, we see in our home that dough making. And what happens here? The dough gets changed in its shape every now and then, where the muscular force is applied on it. So again here I request you to write your own answers. The next question is that fill in the blanks, right? So here we have to draw water from the well, and when you draw water from the well, what do you have to do? Very simple, we have to pull. Okay, you have to pull the container which is tied with the rope and which takes on a pulley, isn't it? There will be a pulley here, one rod like, and this goes down and there's a container here. So that we have to pull it here. So answer will be pull. The next question. A charged body and uncharged body, what happens between them? Okay, if you bring near. I've already shown you how to charge a body. Okay, just by rubbing you can charge a body. Right? And when you bring a charged body near an uncharged body, as you have shown in the demonstration, what happens is the charged body, in that demonstration it was a straw, isn't it? Attracts an uncharged body, right? Quickly we'll go for the next one. Again in the third question, C. To move a loaded trolley, simple one, we have to dash it. Sometimes you have to pull it, sometimes you have to push it. Simple one. Either you write pull or push, both are right answers. Next, north pole of the magnet is brought near the north pole of another magnet. What happens? You must have done this experiment. However, you have seen many types of magnets, and every magnet will have one common property. They exist in two poles, and one pole is called south pole and this one is a north pole. Right? So you can bring this magnet in this way, south and south facing each other, or north and north facing each other, or south and north facing each other. So when you are bringing in these two cases, south and south facing each other, north and north facing each other, they are the like poles, isn't it? And whereas here, unlike poles. And remember, when unlike poles, right, here it is like poles we have faced each other, right? When the like poles are brought near, what happens? Remember, they repel. You all have done this experiment, and unlike poles attract. But the question is that north pole is brought near north pole, and therefore N and N are facing each other and they are like poles, and therefore what happens? They should repel. Okay, quickly we'll go for the next question. We shall try to finish as many as questions because already the content is discussed in the video lessons, right? And here is a question which is again a fill in the blanks question, and this question speaks what you have to do here in between. You have to take a pause and read, because sometimes my reading may be a little bit more with more speed, so you may not go along with what I speak. So take a pause sometimes and read and then play the video again, right? So archer stretches her bow while taking aim at the target, right? So visualize this. Archer stretches the bow, stretches, right? Archer stretches the bow. The bow was not in this shape before. The bow was not in this shape before, and she stretched it, and now the shape is changed. After that, she then releases the arrow, and the arrow begins to move towards the target and hits the target. There are some words which are given: muscular, contact, non-contact, gravity, friction, shape, and target, attraction, sorry. Now you have to pick up these words and fill in the blanks, right? We'll go here, visualize this problem properly. Now what we have done, we have seen this archer stretching it and changing the shape of this bow. To stretch the bow, the archer applies force that causes change in its, what should we write? What happens to the bow? Bow has changed in its shape, right? This question over. We'll go for the next question, right? So here this question is change of shape. We'll go for the next question. Question B. The force applied by the archer to stretch the bow is an example of dash force, right? Now here bit of confusion. Okay, we just look at this. Now the force applied by archer to stretch the bow is an example of muscular force. Yeah, it's true. Contact force, it's true. Right? Now can we pick up any of these? But wait, we have got very few left here. So let me pick up, let's say this, because I don't know, maybe this is required for the next answer. If not, then we'll come back again. Right? So here I'll use contact force. The next one. C. The type of force responsible for a change in the state of motion of the arrow is an example for change in the state of motion of an arrow is an example for, now contact is already used. Now we can go for muscular force. So answer is muscular force, because we are using the muscles of the body to pull it, right? The type of force responsible for change in the state of motion. State of motion is changed. It's going fast, right? The next one, D option. While the arrow is moving towards the target, the force acting on it are due to dash and that due to dash of air. Look at this. Okay. While the arrow moves towards its target, the force acting on it. Now target is moving front. Arrow is moving front. Okay. Arrow is moving front. Remember, there are two forces which are acted on it. Can you tell me which are those two forces? The arrow is not supported by anything. It's moving just in the air. And when it is moving in the air, it is rubbed with the air. Means the air is in opposite direction here, and it has to pierce through the air and hit the target. That means its speed will come down. Due to what? Due to a force which is again a contact force. And what is that force called? Friction force. Because that word is here, right? There is a friction between the air and the arrow. But wait a minute. While the arrow moves towards its target, the force acting on it are due to, what is that? This arrow is also pulled by the force of gravity, because gravity is here. Earth is pulling it, right? So here gravity should come. So answer is, while the arrow moves towards its target, the force acting on it are due to gravity and then due to friction of the air. Is that clear? Okay. Now, the next question. The next question is, now here in the following statements, identify the agent exerting the force. Understand this? Identify the agent exerting the force. Means who is applying the force. And then the object on which the force acts. Means you have to identify two things here. One is who is applying force and on what the force is applied. And then you have to say, state the effect. What has happened to the object? What has happened to the object? So first thing what you should know, that you have to identify the agent exerting the force, who has applied the force, and then on what the force is applied and what has happened to the object after application of force. Basically it is speaking on effect of force, right? The first one is, squeezing of lemon. So we'll take one by one all these things. 4 options, the 4 situations are given. The first situation, here we go, squeezing of lemon. And what happens when we squeeze the lemon? The juice comes out, lemon juice, right? Now who is applying a force? A person? It is better to say fingers. Agent is a fingers. Where do we apply? Actually between the fingers we keep the lemon and then squeeze it, right? So who has applied? What is the agent which has applied the force? Fingers, right? And second, the fingers have applied the force on what? What's the body? Body is lemon. Okay. Then what has happened after that? What is the effect of force? The lemon has changed its shape. So how you have to write this answer? The answer to this you have to write like this. What is the agent? Agent is fingers. Object is the fingers applied force on lemon, and then effect is change of shape. Right? Quickly we'll go for the next one now. Taking out the paste from the toothpaste. We all do that every day. So again we have to write, we have to find out agent. Now it is very clear for you. Then you have to say what is the object on which force is applied, and then what has happened, the effect of force. So who has applied? How do we apply force? Again fingers. Right? Again fingers. Right. Then what is the object? Is it lemon here? Is it lemon? No, lemon is the wrong answer, right? And what should be here? In place of lemon, it's a toothpaste, isn't it? It's a toothpaste. We are applying force on toothpaste, and again what has happened? Change in shape. Right? Again what has happened? Change in shape. So lemon is the wrong answer here. We have to go for toothpaste. I hope you have understood. We are using a fingers on an object, what is called toothpaste, and then effect is change of shape. Next one. Now This is some different. A load is suspended from a spring. So this is the load. And it is suspended. It is fixed to the hook here, to the spring. This is the spring. Right? And one of the end of the spring is fixed to a wall or a support. So this is not getting out, coming out. It is fixed. Now what happens here? This load will pull the spring down. The spring earlier is just this much. Now when the load is pulling it down, what happens? It becomes lengthy. Right? Now again here you have to write what is agent who has applied force here. Tell me, who is applying the force? It's a load, isn't it? And who has applied force on the load? Right? It's earth. Why this load goes down? It's because of Earth's gravity. But here either you can write earth or load. So load is applying a force on the spring, and then object is spring, and then what happens to the spring? Again change in shape. So agent is load or earth, object is spring, and effect is change in shape. The next one is force and pressure. Next one is an athlete making a high jump to clear. An athlete making a high jump to clear. So you all have seen and sometimes participated in the high jump event in the school. What we do, we'll go and take a run for some time, and then suddenly we push the floor, that's the ground. And when we push the ground vertically, our body gets up, right? And then when we jump up, we make clear the bar here. Okay, so this athlete is doing the same thing. The question is, when this is done, who is the agent who has applied force? Who is applying the force? Right? Athlete, actually. Athlete is applying force. Understood? Unless athlete applies force on the ground, he or she cannot jump up. Right? And therefore, where athlete is applying a force? On ground. So that's the ground, isn't it? And through legs she is applying the force. Okay. And what is happening to the body? The body was going straight, horizontal, in one direction, and suddenly there is a jump. So what happens? Change in state of motion, change in direction, change in speed. Altogether we can say change in state of motion. Okay, the effect is change in state of motion, or even you can say change in direction, because the athlete moves straight and then takes a vertical jump, isn't it? So change in direction. Change in direction again means a change in state of motion, right? So this is the answer for it.